So in this tutorial, I'm going to be showing how to use the SIC MPU9250 IMU with the Raspberry Pi. In previous video, we showed how to use it with your PC, but you can also use it with the Raspberry Pi in your robotics project. So this is a robot I've been working on. So you notice that the Raspberry Pi is powered by this buck converter, the XL4015. I got it on micro scale here in Nigeria. It's using battery, a 7.4 volt battery. So this steps it down to 5 volt and powers the Pi. And for me, using it is actually a very good buck converter. So now to the tutorial proper. So the module has been connected via the FTDI module connected to a USB extender. I'm going to be connecting the USB extender to the Raspberry Pi. So that's how to connect it to the Raspberry Pi. So I'm going to be SSHing into the Raspberry Pi. Which I'm going to be SSHing into it. Yeah. So I'm already in the Pi. I also do that for these other two terminals. So I'll be connecting to it via the VS Code. It's almost. So we'll be installing the ROS2 driver package for the SIC MPU9250 IMU. And I earlier said, remember it's connected to USB extender, then to the Raspberry Pi. So I'm going to be doing that quickly. It's similar to how you did it on the PC in tutorial I did here previously. So this we are going to update, then install this lib serial for serial communication. I've done that, and I've also installed in ros-dep on my Pi. If you have not done that, just run all these commands. But the next thing is to go into my SRC folder of my ROS workspace and clone the repo into it. Yeah, cloning this SIC MPU9250 repo, cloning it into it. You can get it from the documentation. So, after that, I'm going to go to my ROS workspace on the Pi. So I'm going to the SRC and clone into it. Now I'm also connected via SSH VS Code. If you notice how I'm on the ROS workspace here. As I did appeared, it has shown here SIC MPU9250 ROS. Yeah, so that's how I've cloned it. So the next thing is to install all necessary dependencies. I'm going to copy this. Copy this out. So what this is doing to go back to the root workspace and check for any dependence. So all dependency installed successfully. So after that, the next step is to check which port the driver module is connected to, which of the ports it is connected to. I'm using this by path. I'll be checking with by path. Since I'm connecting multiple devices to a robot via the Pi, this is a motor driver here, which is also connected to the serial port, while this is the IMU connected to the serial port. So if you're using multiple devices, it's better you use the by path so that's a specific port. It doesn't change. Unlike when you use USB 7, USB 1, it can easily change. So I'll remove that of the motor driver so I can confirm the ports of my of the IMU. So I'm going to copy this, confirm the port. Yeah, so this is the port where it is connected to. Yours might be different, just copy it, Ctrl-Shift-C. So I'm going to go. So once I've gotten the port, said go to the config folder inside this SIC MPU9250 ROS package. Then you see 2 param file. Just change the port value. Yes, and we don't need to change any other parameter. So let's change the port value. I'm going to go to the folder, to the config file. I'm going to open both of them. In test param file, can see I'm just on comment this out and change this port value to that which I've got. Yeah, that's what I'm going to do. I'm going to do the same thing here. Comment this. This is just a basic difference. So when I say it, when I did it with the PC there, yeah, I'm using the by parts method. So once I've done that, I don't need to touch any other parameter there. So the next thing is to build it. So your ROS workspace folder, just build package. So I'm in my root and ROS workspace folder. I'm going to build it and copy this. After building, we need to we need to test the SIC MPU9250 with RViz. Yes, so they just need to test it actually. So we're going to run this particular command on the Pi because we have installed it on the Pi, and the Pi is running the ros-humble-base, and the our dev PC is running the ros-humble desktop. So the Pi does not have RViz, so we need to run this on our desktop PC where RViz is installed. While we're running this test command, we're running this on the Raspberry. I'm just going to open a new terminal, connecting to the terminal again. So once anytime I open a new terminal, it also sources my workspace. So that's just what I'm doing. But if on your own, can source your workspace. I'm going to run this launch file. Now, once I launch it, you get to read. You notice the LEDs blink. It takes about 10 seconds for it to boot up and process. So now it's ready. Okay, you notice the LEDs are blinking, means data is being transferred. So how would I view it? So now this is my PC, Samuko PC. This is my dev machine. So I'm going to just run RViz on my PC, RViz2. I'm going to run RViz2 on the PC. Then I'm going to add the TF display, transform display. And this, the test ensure it's publishing on the map frame. So now you can see that it's working. Yeah, it's working. Yeah, so we see that it's working. So that's just how to set it up on Raspberry Pi. Your visualization will be done on your dev PC, while the other part, the reading of the IMU, is be done on the Raspberry Pi. So that's basically how to do it. Yeah. So I'll just close this. I can also close this. Okay, before closing, I want to just show you one or two things. I'm going to I want to view the ROS topic. The ROS topic list also. So you can do this on your dev on your Raspberry Pi, and just want to do it on my dev PC. So you notice that it's the same, both the dev PC as well as the Pi is saying the data transform IMU data RPY. So I can ROS2 echo and notice that it's printing out the covariance, orientation, quaternion, and things like that. So it's working. Okay, that of the RPY also is working. It's printing out the data in row, pitch, and that's rotation about X, Y, and Z. So it's all working. So that's basically how to set up the SIC MPU9250 on your Raspberry Pi. As soon as I stop the connection, you notice that there's no more blink, there's no more transferring the data. So that's just it. So now for the other parts, notice there are two config, and there are actually two launch files, the start and the test launch file. There's a start launch file, there's a test launch file. So the test launch file is just what we just did. What it's doing is that it's publishing on, it will publish the IMU transform on the map frame. So that's just what the test is doing, so that you can visualize it. So it's just for testing and visualization. But the stats is when you are using it in your actual robot, which in future tutorial I'm also going to show how to really use it. That you need to have your robot's URLDF. So your robot state publisher will publish the transform. Your robot's URLDF will have an IMU link. So now the name of your IMU link must be the same as that of this frame ID on the stats param. So that's just what you need to take note of. So once the robot state publisher publishes your URLDF, then any data that is being published on this frame will be published on that particular IMU frame on your URLDF. So that's just basically how to use it. So when you're running a real on your robot, not necessarily testing through a URLDF, so this is what you use. Just ensure that this frame ID is the same as that of the IMU link in your URLDF. So that's it. Thank you.